Hi guys, and welcome back. In the last video we talked about an example of the product rule. We talked about the quotient rule and we did some examples with that. So in this video what we're going to do is we're going to do some bookkeeping with exponents, and really what I mean is we have to define what the zero exponent is. So the zero exponent. So what I mean is something raised to the zeroth power. We want to know what that is. It turns out we actually define this. We define what the zero exponent will be. So we define what it is. But before I tell you how we define it, let's kind of see the motivation for it. So let's just say we're looking at, let's say we have 2 to the third over 2 to the third. Let's just think about what that is without any use of the properties of exponents, just thinking it out. Well, we have the same thing on the top and the bottom, right? And neither of them are 0. So we have 2 to the third, which is 8, and then 2 to the third, which is 8. You know, these are both the same, right? So whenever you divide a non-zero thing by itself, you always get 1. But now, let's go ahead and think about that same exact problem, but instead we're going to use the quotient rule we just developed. And I'll just recap what that is. Quotient rule says that if you have a to the m minus n, it's the same thing as a to the m over a to the n. But now let's think, so coming back to this, let's think about this problem now in terms of the quotient rule. So we're in this situation where m and n are both 3. So really, what we got to do is we've got to subtract them, right? We've got to subtract them. So we've got to do a to the, we've got to do, we're using 2 now, we got to do 2 to the 3 minus 3, which is 2 to the 0th power. Well, we don't have a definition for 2 to the 0 yet, but we'd like this quotient rule to be satisfied with it. We want it to be consistent with the quotient rule. So the way that we always define anything to the 0th power is we always define it to be 1, because we want it to agree with what we get with common sense by evaluating it without the properties of exponents. So so here's a nice picture to illustrate what I mean a little bit further. Let's say that we've got, let's just say we've got something like 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, and 2 to the 0th. Let's say we're looking at this. Well, if we evaluate each of these, 2 to the 4th is 2 times 2 times 2 times 2. Well, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. And notice, each time as we move up each step, we're multiplying by an extra factor of 2. Or, viewed differently, as we're moving down, we're just dividing by 2. So the next number would be 8. Dividing by 2 again, we get 4. Dividing by 2 again, we get 2. And then what do you know? Dividing by 2 once more here, we get 1. So this is another kind of a justification of why 2 to the 0 is 1. It's seen a little more pictorially than up here, the way I explained it. So yeah, that's why the zero exponent is defined that way. So the only kind of like extra nitpicky detail is what happens when you have 0 to the 0. And for this class, we're just going to assume that something of this nature is undefined. Sometimes it's defined to be 1, but we're just going to say this is undefined and leave it at that. But anyway, that's the end of this video. In the next video, what we're going to do is we're going to look at what negative exponents are and how those rules work. And then we're also going to look at the power rule. We're going to raise a product to a power, and we're also going to raise a quotient to a power. So that might not all be in the next video, but that's the remainder of 1.6. It might be cut up into a couple of videos. But yeah, that's the end of this one, guys, and I hope you enjoyed it, and we'll see you in the next video.